Alright, so here we're going to deskew the probes. Basically what deskewing is, in simple terms, is basically to correct for the propagation delay of the individual different types of probes, whether it's voltage probes, current probes, differential probes. And if you're using dissimilar probes like we will be when making power measurements, you don't want to introduce any delays that could interfere with measurements like switching losses and gate conduction. So just to eliminate any measurement error, Tektronix has a really handy database of deskew factors for all their probes, but let's actually see how we would figure it out. So to do this, we're going to use the AFG function in the MDO, and you could do this on the same box, but we're going to use two separate oscilloscopes to demonstrate it. But we'll press AFG. We're going to bring up our output menu first, make sure we're configured for 50 ohm output, and if you go to the datasheet for the AFG, the maximum allowable amplitude, which we want because that'll give us the greatest slew rate. So we're going to go for the maximum allowable, which is 2.5 volts peak to peak into 50 ohms. It can only do 5 volts peak to peak in high Z. If you wanted more, you could run this through a half bridge or any kind of amplifier, but just directly out of the scope, we're going to set it to 100 kilohertz because that's where we're making most of our measurements at, since we're working with power supplies. You could do this at a higher frequency if you're going to be using the probes at higher frequencies, but this is well within the range of all of our measuring probes, current and voltage. So once we enable the output and we connect up to the AFG output, basically in parallel all the different probes that we're using. We have a single-ended passive probe as well as some active differential probes, high frequency and otherwise. So basically you'll get a pulse output, and what you want to do is overlay the two waveforms one on top of the other. And we're really not interested in amplitude, we're interested in the time domain. So it almost looks like these two are almost perfectly aligned with zero propagation delay. But as we say in electronics, nothing happens at exactly the same time. So let's zoom in a little further. And as we go in further and further, we'll see there is actually substantial error between the two, which could get translated into our power measurements. So what we want to do is to align these. Right now we're looking at about 10 nanoseconds per division, which could be a problem at high frequencies. It can't necessarily, we would prefer not to ignore it if we don't have to. And Tektronix has a nice feature in their scopes called deskewing, where it's within the probe menu. If you go to the probe you want to deskew, in this case, we want to deskew our active probe, which is a little bit more delayed than the passive probe. So we're going to select that channel, bring up its channel menu, and from more, go into the deskew menu. So for channel 3, which is our active probe, you can either manually enter a deskew constant or you can select from their database. If you're using a Tektronix probe, you can go to their database and select the probe that you're using, and it'll give you a recommended deskew factor. And in this case it's a P5200 high voltage differential probe, and then set deskew to recommended. And here you see it actually did a pretty appreciable job just with the built-in value in their database. If you were using a non-Tektronix probe and wanted to do this yourself, for example with our current probes, or a third-party probe, let's go back to where we were. So now we have two probes that are out of sync due to propagation delay. This is really just a measurement error. We'll go back into the deskew menu, and assuming that we weren't using a supported Tektronix probe, we would select manual deskew, and using the B multifunction knob, we're going to adjust this and basically keep adding in an appropriate amount of deskew until the two waveforms are in phase. And here you can see I'm dialing in however much deskew I need. And if either the database value wasn't correct or you wanted to dial in your own, you can do it this way. And here you can see we dialed in 13.5 nanoseconds of deskew, and that's right on for this probe. Now you can see our measurements are going to be very accurate. it slews at about almost the same rate as our passive probe. And considering it's a 1300 volt high voltage differential probe, this will give us fairly accurate power measurements. So basically you can repeat this process and overlay the current probe waveforms and any low voltage differential probes or other active probes that you're using to make in-phase measurements. And a good example is